Okay, so welcome back again into another video. So in this video we're going to start a new playlist which I want to discuss with you about the general reactions which we are encountering mostly in biosynthesis methods. So if you are familiar with the biosynthesis of steroids, polyketides, cocaine, likewise the more complex molecules, these biosynthesis pathways are consists with so many general reactions, right? So in this video list we are going to talk about these general reactions and how they operate in a biosynthesis pathway. Okay, so the first one is the alkylation, which is most common thing among the biosynthesis reactions. There are types in alkylation. So the first type we are going to talk about is the oxygen and nitrogen alkylation with SAM. This SAM is very important. This is a molecule. Right here I have mentioned it. So the SAM is we commonly say as sulfur adenosyl methionine, right? So this is the molecule which we denote as SAM. This is the SAM. This is SAM, right? This is SAM. The most important thing is let me take a color. Okay, let's take this one. This here we have a methyl group, and here this is important. This is our sugar part. We denote it as AD. This adenosyl part, right? This is a sugar part. So when you are looking at this SAM molecule, you don't need to memorize this structure, but you need to have an idea about this sulfur center, right? So you can memorize it like this. So there should be a methyl group, right? And there should be this chain NH2 group and CO2H group, and here to sulfur we have a sugar group. This is all you need to memorize, right? And important thing, there is a positive charge. You know, sulfur has 6 valence electrons, right? So 1 2 3, and there is another 2 electron pair and 1 electron is missing, so it's a plus charge, right? So now how this SAM molecule involves in this alkylation process, right? So let's say we have a group like this ROH. Okay, now what happens is, you can see this sulfur has a positive charge, so it needs electron density. So what happens, it will break the bond in here and take those electrons, because our oxygen over here will attack to this particular methyl group, right? So now what happens, we will have ROCH3, right? So this the remaining part will be removed. So this is the basic reactions for alkylation process. So SAM is the most common reagent which we are using. The same happens for NH2, right? So here we have a double bond over here, so this will go and attack to our CH3 group, so this bond will be broken. So we will have, from this reaction we will have RNH2 and CH3, kind of this. So these are the basic thing you need to understand. So this is pretty easy, right? This is pretty easy, but the thing is, when it comes to the biosynthesis methods and biosynthesis processes, these are becoming a little bit complicated. So now let's move into our next type, which is simple B, right? So carbon alkylation with SAM. Now you know what the SAM is, and you know the structure of this SAM. So as I have told you, you don't need to memorize the structure, but you need to have the common idea like how this SAM works. So you need to know that there's a sulfur and there's a methyl group, and there is this sugar part, and there is this NH2 and CO2H group, and there is also a positive charge. So you need to know that. You need to know about this thing. You need to know how to draw this thing. So I hope you get the idea. Okay, now when it comes to C alkylation with SAM, okay, so what happens is, let me take an example to explain it to you. So I will take yellow color. So let me take an example. Okay, let's take a molecule. Okay, so let's take phenol. It's a pretty good molecule. So here we have OH. So here, okay, now you know, with the structures, like with the resonance structures, this double bond is can form a this electron pair can form a double bond here, so which makes this bond to break to here. So we can draw it like this. I know you are familiar with this, guys, right? So here we have a negative charge and double bond OH. Here we have a positive charge, and the two bonds stay the same. Now here we have our SAM with our sugar group and our NH2 CO2H. Great. Okay, now what happens is the same thing which we have discussed over here, right? Here you can have a nucleophile over here, negative charged electron pair, so it will go and attack to our methyl group. What happens now? There's a positive charge on the sulfur, so sulfur needs electron. Due to this pressure, due to this effect from the outside, this electron pair will be broken to sulfur. So we will have our final product, right? So like this, CH3 over here. So again, you can do it like this, right? Basically this resonance structures, right? You get the idea about the phenols and its resonance structure, right? Okay, now this is the basic reaction which we have to know when it comes to the carbon alkylation with SAM, right? But there's a little bit twist here, like not all the molecules undergo the carbon alkylation with SAM. You can see in this particular example there should be a nucleophile, right? There should be a nucleophilicity, like in higher, like the higher electron density on a particular carbon in order to attach a methyl group, right? Like you cannot attach a methyl group to this carbon, right? Because it lacks nucleophilicity, it lacks electron density to donate, it lacks electron density to attack to this particular methyl group, right? If your carbon contains enough electron density to attack this step, right, this attacking can proceed from your particular carbon atom, then it can be go through with carbon alkylation along with SAM, right? The perfect example is these guys, right? So you know that this is an alpha carbon, right? This is an alpha carbon. This is an alpha carbon. So which makes these alpha carbons two hydrogen atoms. There are two hydrogen atoms on this alpha carbon. These are much more acidic than the normal carbons because of these carbonyl groups. So what happens is it can form enolate ions, right? So now here at this particular carbon atom there is enough electron density, or there is a nucleophilicity. So what happens is now you can react it with our SAM. NH2 CO2H. Here we have positive group. Now here you have the nucleophilicity here. It will go and attack to our carbon center, which resulting in the breaking of this particular bond. So what happens? We would have this particular molecule. So I hope you get the idea about how the carbon alkylation works with the SAM, right? So this is very important when it comes to most of the reactions, right? So let me go to another small example. So and also before I go into the next example, like you may wonder, right, this is also alpha carbon, right? This is also has a acidity. Why this place doesn't react with our SAM? It can, right? So you know these are chemical reactions, so this is not the only product, right? There can be other products also, like this one. this product can occur, but the stability, right, uh, the probability of gaining this particular product is very low. Why? Because this is very much acidic. This is very much acidic compared to this one. So when you know, in order to form this unit ion, you need a base, right? You need a particular base. So the base more often, like, it prefers to attack this particular hydrogen because it has high acidity rather than this. The basic concepts in biochemistry, right? So we will talk about these things, these reaction steps, and these tendencies more often when we go through our next videos. So I hope you get the idea. And another simple example with this is also like this. Look at this one. The same thing happens, right? This particular carbon has more acidic hydrogens, so it can form its anion form here. Now it have an anion form. Now what happens is our SAM can be attacked from this particular nucleophile. And here we have a positive charge, and it will go and attack to our methyl group. The bond will be broken. Our final product can be obtained like this. I hope you got the idea, right? This is very important. This SAM reaction is very much important, so I need you to go through this, and you need to get the idea, like, you need to understand this reaction, right? So we will, in next video, we will talk about the DMPP and the same alkylation method with DMPP. So thank you, and don't forget to subscribe.